Hi Year 6, thanks for your hard work in the lesson. As I promised, after I've marked your books, I've had a look and seen the bits that some of you aren't sure on, and I've created this video to help you with algebra and solving equations. So I'm going to work through a few examples and talk out loud and show you how I'd solve them. And then I've set you some homework tasks on my maths, which I'd like you to do for me before I come back next week. And make sure that you do your working out and bring it with you so that I can see what you've been doing. Okay, so if we're going to solve an equation like this one, 3x plus 2 equals 14, remember what we're going to try and do is to isolate the letters on the left-hand side. So in this equation, we want to get x to the left-hand side and then have a value on the right-hand side of the equation so we know what x is worth, or we know the value of x. So the first step here is to subtract 2 from both sides, so that I'm just left with 3x on the left-hand side, and then 14 take away 2 is 12. Now if 3x is 12, I can divide both sides by 3 to find x. 3x divided by 3 will just leave 1x, but I can just write x, which equals 12 divided by 3, which is 4. Okay, now let's start getting the process a little bit more mathematical. We're going to set up an equation and then solve it. So imagine I'm thinking of a number. Let's call that number x. I'd multiply it by 3, so I've got 3x. Remember, of course, we don't need a multiplication sign. Then I subtract 1, so I've got 3x minus 1, and my answer is 14, so I can write 14. So that's an equation there which describes the number problem I've just said. Okay, so to solve this equation, the first thing we're going to do, remember we're trying to get x on the left-hand side of the equation and a value on the right. So to just leave 3x on the left-hand side, I need to add 1 to both sides of the equation. So that will leave me with just 3x on the left-hand side, because minus 1 add 1 leaves nothing, leaves 0, and then 14 add 1 is 15. So if I divide both sides by 3, I'll be left with just x. X equals 15 divided by 3, which is 5. I'm going to look at a slightly more complicated example this time, where there's a variable or a value for x on both sides of the equation. And this will involve a few more steps, but I'm going to talk you through it. We're still trying to do exactly the same thing. We're going to try and get the x's on the left-hand side and a value on the right-hand side of the equation. And we're going to make sure it balances, that whatever we do to one side, we also do to the other side of the equation. Okay, so first of all, I'm going to look at this and I'm going to move the x's to the left-hand side. So to do that, I need to subtract the 4x from here on the right, and then also subtract it from the left-hand side. So 6x take away 4x leaves 2x. I've still got the plus 7, and that equals 4x minus 4x, which is 0 x's, so I don't have to write them, and we're left with 19. I'm now going to repeat this process and subtract 7 from both sides, so that on the left-hand side I'm just left with 2x. So 2x is on the left because 7 take away 7 leaves nothing. And then I do that to the right-hand side as well. So 19 take away 7 leaves 12. And from here I can simplify and divide both sides by 2. So I know that x equals 6. Okay, let's look at another equation where there's a value for v on both sides of the equation. So the first thing I'm going to do is to add 2v to both sides. And that just leaves me with 28 on the left-hand side. And 4v add 2v is 6v. And then I've still got my plus 4. Now the reason I've done that is to get rid of a negative value for v. I could have brought it to the left-hand side, but then I would have taken away 4v from both sides and ended up with minus 6v. Now if you're anything like me, I find positive numbers much easier to deal with than negative numbers. So if I can avoid it, I would rather add the 2v and have a positive value for v than subtract 4v and end up with minus 6v. Sometimes you do end up with a negative value and there's not really anything you can do about it, but if you can avoid it, then I'd recommend you do. So the next step then is to subtract 4 from both sides. So I end up with 28 minus 4, which is 24, is equal to 6v. And of course now I can divide by both sides by 6. So I end up with v equal to 4, because 4 times 6 is 24. Now something a lot of you weren't sure about in the lesson was equations which involve brackets. So I'm going to talk you through how you'd solve these, just some basic ones, and then when you're in the booster session with me again, we'll move on to some harder examples if we're ready. So if I've got 3 and then some brackets, x minus 6 equals 18, what you need to do is to expand the brackets. And to do this, you need to multiply both terms which are inside the bracket by the number outside. So in this example, 3 times x would give us 3x, and then 3 times minus 6. You need to be really careful with this because some of you weren't sure when I was in with you in class. If you have a positive number times a negative number, that leaves us with a negative. So 3 times minus 6 is minus 18, and that equals 18. What you can then do, it just looks like an equation that you've seen before. So we've expanded the brackets and you can solve as you usually would. So I'm going to add 18 to both sides. So I'm left with 3x equals 18, add 18, which is 36. So now I can divide both sides by 3. So x equals 36 divided by 3, which is 12. I've set you some tasks on my maths, so I'd like you to have a go at these so that I can see how confident you're feeling before the next session with me, and then I'll know exactly what we need to do in the lesson. Good luck with that.